Do you ever wonder how come we have a periodic table and it is set up the way it is? Let's have a look to see how it is organized, how we can name a variety of groups of elements on the periodic table. And that'll be a good step to better understand how matter is made of. And it's part of a series of videos on chemistry. So my name is Alain Faber. I've been teaching science for more than 25 years. I teach science, I do videos for my class, and I take segments of this live to be able to answer their questions in class, especially for students that sometimes are not in class or they need review. I do it live so that I can answer any clarifications, questions you may have about science. So on this, welcome to our channel. So here we have an interactive periodic table. So for people that are with us, I'm going to put the link here in the comments so that you'll be able to follow along with us. So there we go. So this interactive periodic table, it's a website called PTable, and let's see if we can better learn about it. So let's see. Perfect. So this is the periodic table. The periodic table is a table that organizes matter that we have in our atmosphere, on our planet, and elements, matter that we use in the industry and that is surrounding us. And the question is, it is organized this way, and there's colors, and the question is, how come there are some columns here, some groups of colors here in the middle, and we have a variety of colors on this side. The reason why they're colors, and here we have columns, is that some elements have similar properties. So if elements have similar properties, the question is it possible to see if we can organize them to have an easy understanding, and it's like a reference table for us. When I do chemistry in my class, I always say that the periodic table is like our cheat sheet. When we understand the periodic table and we can use it, they can use that table in tests, in evaluations, or when they talk with friends as a quick reference to include information in what they say. So when we look at this periodic table, there's a few things we need to look into. So I'm going to start with hydrogen here. So the periodic table has some specific information. So the first one we have the symbol and the name here. So here this is hydrogen, the symbol H, and we have the name hydrogen. So this is the French periodic table. So I'm going to switch it to English because I just did a video in French about the periodic table. So here I'm going to go to English, and then we have an English periodic table. Interestingly enough, if you're interested to see it in different languages, it could also be something fun for you. So we're going back to our periodic table, and we have hydrogen here. The other two pieces of information that I would relate to you today is the fact that we have a larger number in the upper left corner of the square here and a number at the bottom. The upper part here, it is what we call the atomic number. Each element has an atomic number. So let's see. We have hydrogen that has number 1. We have helium on the other and the last column. And you can see here on the first row, we have 2 elements only. And for the helium, you can see that the atomic number is 2. So here, this is the first column, the first row. We go to the second row, we have lithium here, and here we have an atomic number of 3. We go now on the second row, we have beryllium, we have 4. Here, boron 5, carbon 6, and nitrogen 7. So the first thing to notice is that all the elements on the periodic table have their own atomic number. And interestingly enough, this atomic number tells us how many protons there are in the nucleus. So when you have an atom, and I'm going to do a quick drawing, for example, of lithium. So when you have lithium like this, with here, I'm going to put, so we have this, we have a 3 here. This tells us how many protons there are in the nucleus. So I have a nucleus, we have 3 protons here. And interestingly enough, when we have 3 protons like this, we also have 3 electrons because these are neutral particles. So 3 positive and 3 negative gives us a charge of 0. And each of these electrons have their place around the nucleus. So the nucleus here is where we have most of the mass. We have electrons all around. Perfect. Let's go back to the periodic table. Perfect. So we have the atomic numbers. And if you notice, the atomic numbers go all the way. And I'm going to stop here at uranium because uranium is the biggest atom, or the biggest atom. So the element with the biggest atoms, the biggest particle, that are the heaviest that we find naturally in our environment. And if you look at uranium, we have 92 as an atomic number. So this is 92 protons. Now the number of protons is the identity of the element. Every element have their atomic number because every element have their own identity. Perfect. And here we can see the last number is what we call the atomic mass. The atomic mass tells us information about how the proportion of positive protons in the nucleus and the neutrons. So let's go back to the lithium here, because here, if you round up, we have atomic number of 3, and here you round it up for an atomic mass of 7. So if we look here, we have an atomic mass of 7. In order to know how many neutrons there are in the nucleus, we have 7 minus 3 gives us 4. So here, the most abundant type of lithium atoms have 3 protons always, because that's their identity. And we have the number of neutrons here. This is what we call the nucleus. The nucleus, like this. We have number of protons. Let's put the vocabulary. So we have the protons that are positive. We have the electrons that are negative, and we have here the neutrons that are neutral. Neutrons, neutral. All of these are the particles that make an atom. And here, this is a diagram that we call the Bohr-Rutherford diagram. And I'll see if I can add a video on that shortly. Perfect. Let's go back to our periodic table. We mentioned that here, 92, the element uranium with an atomic number of 92 is the biggest naturally occurring element. So how come we have neptunium, and we have plutonium, and we have curium? And if you see, the numbers keep on getting bigger. So here we have lawrencium, and then you go here for the last bit here with the flerovium. We have here livermorium, and then we have here organism. Here, this is the biggest atom, the element with the biggest atom we've ever noticed. Now, keep in mind that if you look at the mass, we have an atomic number here of 294 between brackets. Here, if you have borium, atomic mass between brackets. If you go into neptunium, we have an atomic, we have an atomic mass of 237 between brackets. And the reason for that is that these are synthetic atoms. So what happened is we have scientists taking small atoms, creating collisions, and hoping they stick together to create much larger atoms. However, quickly these are unstable and they break apart. That means that they break apart so fast that we have no ways of actually measuring information about those atoms. For example, the mass and a whole bunch of other pieces of information. And that's why we have those in brackets. So these are the key parts of information on the periodic table. Now, there are a few other things to include. So here I have, for example, solids. So most of the metals here in black are solids at room temperature. We also have 2 liquids. So we have mercury and bromine. These are two elements that are liquid state at room temperature, and we have gases. So we have the hydrogen, which is the first element. Then we have most of the gases on the right of the periodic table. And there's some unknown, and the reason is that they appear and disappear so fast that we don't have enough of those atoms together to get more information. Okay, so this is the states that is important. Now, the other part that works very well is what we call different groups. So if you look at the periodic table, we have group 1, which is the first column. We have group 2 and group 3. And if you go here, we have a group 15, group 16, 17, 18. So the groups are the vertical line. And you notice with colors, we have, for example, the noble gas. The noble gas right here, they have their own purple column. The reason why they have their own column is that when we put all the elements together to organize that, and by the way, I'm going to create a video that I will do shortly about Mendeleev, which is a Russian scientist in 1868, 1869, who put together all the known elements, and he was trying to find ways to organize them, and that created the birth of the periodic table. So Mendeleev is important. Perfect. So the noble gas have their own vertical column. Here it's group 18 because they have similar characteristics. They have similar physical properties and they have similar chemical properties as well. So by grouping them all together and having a name, that is helping us to organize the periodic table. The next one here are the reactive, the reactive nonmetals. There you go. So here, when I teach to my class, I have the noble gases. Sometimes we can call them rare gases or noble gases too. So as we mentioned here, the nonmetals are often in gas in room temperature, and they are associating themselves together, or sometimes they are mixing with metals. So here we have in greens the nonmetal, and then we have on the left side, so we have here the post-transition metals, we have the transition metal, here the bottom two here line, the lanthanoid and the actinoids. Then we have the alkali earth metals, and we have the alkali metals. So all of those are considered in the metal families. Okay, two groups have similar properties. The first one is what we call the alkali metal. Alkali metals are on the first column. They have similar characteristics. They react to oxygen in specific ways. They react to water in specific ways. They are all solid at room temperature. They conduct electricity quite well. So this is why they have their own groups. And interestingly enough, being on the same column, it's easy to see. The second column here, we have what we call the alkaline earth metal. Here, what do we have? We have a group of metals in the column as well, and they are in the same group. The reason being is that they have similar physical properties and chemical properties. And the reason for that is how many electrons they have on the outer layer of their atom. So here we call the valence electrons, and this will be part of what I will share with you when I talk about the Bohr-Rutherford diagrams in another videos. But here, when we are in grade 9 and we're looking for key families of elements or key groups, we have the alkali metals, alkaline earth metals. We also have what we call the transition metals here in the middle, and often I put those two here together as the transition metals. We also have the reactive nonmetals and noble gases. And some of you say, well, there's a group here called the metalloids. What's up with them? Well, the reason why they are here is that the metalloids are very flexible with their environment. Here, metalloids will be acting differently depending on their environment. So that means that if the metalloids here are in the presence of nonmetals, what they will do is that they will act like metals. So they will create ties, and then therefore you will end up with a specific type of molecules that we call molecular compounds. And that'll be another video. See, the periodic table has a lot of information altogether. Interestingly enough, the metalloid here, if they are in an environment with here transition metals, for example, or they are in line with some of these alkali or alkaline earth metal, what happens is the metalloids being all the way to the right will act as if they are non-metals. So being in between metals and non-metals, they will adapt depending on the environment. Often the analogy I do is that if you think of metalloids as students or people enjoying say jazz music, so what happens is that if they are with people that like classical music, the people enjoying jazz will enjoy they will enjoy classical music as well. On the other hand, if you have metalloids here that are with people that enjoy let's see, popular music, like all of these here, what will happen? The metalloid will react one way because it is with metals. So the metalloids act as both metals or non-metals depending on their environment. And that makes it their own family. And this is the information I have with the periodic table. If you have any question with respect to the periodic table, clarification questions, put them in the comments below. If you have new ideas, new questions about that were raised from this video, put them also in the comments below, because I'm here to answer questions you may have so you can participate more in class and have a better understanding of chemistry. On this, if you haven't done it yet, subscribe to our channel, put a thumbs up, and you'll see every week I have new videos about science. And on this, I'm going to put here on this side or this side, I'm not sure exactly which bit, I'm going to put a link to a new video where we'll be able to learn a little bit more about another science topic. I'll see you there.